Hi, my name is Ryan Ballou, and this year I tested the effect of berberine as a natural alternative to antibiotic treatment of Gregarine cuneata. So I started my science fair working with chickens, and something that we always had a concern about was the possibility of a coccidiosis infection. What coccidiosis is, it's a protozoan that lives in the gut of the host, and it causes nutrient depletion. So it induces malgrowth, malnourishment, and ultimately death in the host. So millions of dollars are spent on meat industry and meat companies annually for the treatment and loss of product due to coccidiosis. So I kind of got tired of hearing about coccidiosis and wanted to find a better way to treat it that conformed to the societal shift and FDA standards of antibiotic usage. Last year, I used two natural additives to supplement my antibiotic: green tea and Sephora flavescens. What I found was that Sephora flavescens was tremendous at eliminating all protozoan growth, and it didn't need to be paired with an antibiotic to stimulate this death. So I had a treatment, but I wanted to know why it worked. So that's where I got the basis for my project this year. I focused on Sephora flavescens, and I found that berberine was one of the main natural compounds found in it. And berberine is already used commercially in Japan, and what it does is it balances human gut health. So it's been used as an antibacterial and other gut infections, and just kind of restabilizes your gut health. So what I did was I used my consumption of chickens, and I used it as a daily supplemental value. So I tested both 2.5% berberine supplementation and 0.25% berberine supplementation. And really what this was to do was to test to see if it worked. And I compared the results of this to an antibiotic, sulfadimethoxine, and a control. What I was able to determine from this first round of testing was that the berberine did in fact mirror the same responses as the sulfadimethoxine, and actually eliminating and prohibiting reproduction of Gregarine cuneata. And the way I tested this was that I took mealworms from each group and I performed a gut dissection, and since that's where the Gregarines grow, and I fixed them to a slide using paraformaldehyde, and then I used DAPI stain, which is a fluorescent stain, and it binds to the nuclei. And because there's a phase in the Gregarine's life cycle where two cell bodies are one, so if you use just a standard light microscopy, it might appear that there's only one cell body when in reality there's two. So this fluorescent microscopy gave me a much more precise count. So then, now that I knew that the berberine worked as a treatment alternative, I wanted to know the ranges that it worked in. So I repeated my experiment, but this time I replaced both the control and the antibiotic treatment groups with other concentrations of berberine. So through testing, I did all the same procedure for the same period of time. And what I found was that concentrations have to be higher than 1.5% berberine to indeed be effective at promoting regression of the berberine concentration. A regression in the number of Gregarines. So from there, what I was able to determine was that even though low dosages of the berberine were still limited the number of Gregarines when compared to the control group, the higher concentrations of berberine produce the same overall effect as the antibiotic. In fact, their errors overlap, which means that the two are virtually the same. So from this project, I plan on expanding it to use FACS testing. So what this does is it really augments the number of cells that you're able to count. So it's going to increase my precision and also allow for me to do a lot more statistical analysis on my overall counts when testing. And I also plan on using ANOVA testing, which is another statistical significance test commonly used with antibiotic testing. That's just really good at showing the effectiveness of a treatment when compared to a control group.